Hi everyone, my name is Jingyao from the School of Design at the Hong Kong Polytechnic University. Today, I am presenting our paper titled Examining Gender-Oriented Design Features in Computational Toys and Kits for Young Children on behalf of my co-authors Tian from the University of Colorado Boulder and Junnan from the Hong Kong Polytechnic University. As our everyday lives become highly mediated by technologies, the importance of introducing computational thinking to young children has been widely acknowledged, which can promote their social, emotional, and cognitive development, as well as cultivate their interest in computing. Currently, young children's learning of computational thinking mainly happens through playing with computational toys and kits, or coding kits. Coding kits consist of three types: physical kits whose components are all tangible, virtual kits without tangible components, and hybrid kits that consist of both tangible and virtual components. As an essential computational learning medium for young children, designing inclusive coding kits is particularly important to welcome young learners of different genders, especially given that computing is a highly male-dominated field. Therefore, we examine gender design features in commercially available coding kits for young children ages 7 and under in this study. Research shows that children form gender conceptualizations and identities at an early stage, around toddlers, and their formed gender identity will guide their everyday behaviors, such as picking toys that align with their gender identity while avoiding toys that they believe for the opposite gender. Note that we followed a dichotomy in gender categorization in this work, and did not include a third or fourth gender because the gender classification of young children is dependent mainly on their biological sex. In this work, we ask, how are genders represented in the designs of coding kits for young children? To answer the research question, we collected commercially available coding kits designed to support young children's learning of coding from sources such as Amazon, Target, Apple App Store, and Google Play. After a wide search, we included 110 coding kits for analysis. We developed an analysis framework to structure the examination of gender-related design features in coding kits from literature about gendered preferences of toy features. The framework includes 3 dimensions: colors, physical forms, and activity types. For example, boys' toys often employ dark colors, are presented in forms like military items and vehicles, and support activities like motion control and constructing artifacts, whereas girls' toys frequently employ pink colors, use the form of dolls and domestic items, and associate with role play, nurturing, and decorating. Even though we developed this framework for data analysis, we want to emphasize that there is no absolute line dictating which features are exclusively for a particular gender. We then employed the framework to deductively analyze the collected kits. For example, with the indie robot, its dark colors like blue and black, adopted vehicle form, and supported motion control activity are all boy-oriented. We also quantitatively count the percentages of each type to highlight the gaps in gender representation in current coding kit designs. In the color dimension, coding kits are dominated by boy-oriented colors. Specifically, 95 kits include boy-oriented colors, while 54 kits include girl-oriented colors. The majority of kits mix colors of different genders. For example, the Botley is covered in blue, gray, and yellow, a mix of boys and gender-neutral colors. Although the kits are in mixed representation colors, boy-oriented colors still dominate the designs. This table shows the distribution of gendered physical forms in coding kits, which are mostly boy-oriented. More than half of the kits adopt boy-oriented forms, while only a few kits employ girl-oriented forms. The figures above the table show examples of 2 most commonly boy-oriented physical forms in coding kits: the construction bricks such as the Lego Coding Express, and vehicle forms like the indie robot. As shown in the table, only 13 kits employ girl-oriented physical forms. The figures above the table show a stuffed animal from the Mochi kit and the icons of domestic items from the Rocket Cupcake Company kit. Both represent girl-oriented forms. In terms of activity type, boy-oriented activities also dominate the collected kits. Over 100 kits support boy-oriented activities, more than those supporting girl-oriented activities, which is 29. Remarkably, constructing artifacts and controlling the motion of physical objects or virtual characters are common boy-oriented activities, such as the Lego Coding Express and the Indie Robot, as shown here. Girl-oriented activities are identified in only a small portion of mixed represented coding kits. For example, decorating kit, like the Kibo, is a girl-oriented activity type. Also, as highlighted in the table, there are no activity types that exclusively are designed for girls. Notably, gendered features of different dimensions often coexist in one design. For example, the Reiwa robot kit employs pink and black colors and is presented in the physical form of a military robot. Our findings show that all three dimensions commonly adopt boy-oriented features while girl-oriented design features tend to be marginalized. As such, we suggest employing gender-oriented design features from multidimensions in one design for a specific gender, especially for girls. Additionally, our findings show that girl-oriented activities in some kits are coding-irrelevant activities, such as decorating, which may fail to contribute to increasing girls' interest in coding. So, we recommend that future kit designs can expand girl-oriented activities through a meaningful combination related to coding. Lastly, our analytical framework is developed from previous literature on young children's gender perceptions of various toys' design features. So it can be applied beyond the context of coding kits to other types of toys and learning technologies for young children. This framework can serve as a reference for researchers, practitioners, and designers to examine the gendered design features of existing toys or design more gender-inclusive learning technologies. However, we are not arguing our framework is comprehensive. It should be used critically rather than as a doctrine. For example, some design features are beyond the scope of our study because we did not find direct evidence from prior studies, such as robot-shaped forms and storytelling. Also, our framework does not capture the compound effects on a mix of gendered features of multiple dimensions. Moreover, the gender orientations of specific gender features are not static but a dynamic process depending on the changes in social norms or sociocultural environment. As such, this gender-related design framework is time-sensitive and should be consistently verified and updated. In our future work, we will invite young children and parents to empirically evaluate the gender orientations of representative coding kits' design features and expand our analysis framework. This is an overview of our paper. Thank you for listening.